Alright? This is linear inequalities. These are your inequality symbols. This is the less than symbol. This is your greater than symbol. This is less than or equal to. And this is greater than or equal to. Now the key thing with these are the types of lines when we go to graph, the types of lines that these get. These two symbols get dotted lines or dashed lines. So you get also dotted lines in between there to show that those are dotted lines. The symbols that are less than or equal to are going to have solid lines. Okay? The way I remember that is if they have a line underneath it, it's a solid line. It's something easy for me to remember. When we go to graph, this is important. If it's less than, you're going to shade below. If it's greater than, you're going to shade above. So always remember that. You always have to remember the type of line it gets and which way you're going to shade. If it's less than or equal to, it's going to shade below. If it's greater than or equal to, it's going to shade above. If it's one of these symbols, it's going to get a dotted line. If it's one of these symbols, it's going to get a solid line. The reason being, the solutions cannot fall on this line. Solutions can fall on this line. So there's a little added note if you want to write that down. Solutions don't fall on a dotted line, but solutions can fall on a solid line. So those are your symbols to help you out when we go to graph. Alright, so step off camera real quick. With these symbols, we're going to practice using them. And the two keywords that we need to know when we go to real world problems. The first keyword is at most. At most is always going to be the less than or equal to symbol. Okay? At most is less than or equal to. At least is going to be greater than or equal to. You'll see these two phrases in word problems a lot, as these examples show you. Coach Prince can keep at most 12 players on his team. So if we just say players, that was bad. Player on his team, we'll represent that with the letter P. By modeling the situation, I would just say P is less than or equal to 12. Because the players on his team can be anything less than 12 or equal to 12. So it could be 12, it could be 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, or 0. Okay? So that's the model for that situation. If I have at most, it's going to be less than or equal to. With at least, it says there were at least 450 students who passed the 8th grade. So my subject here, the students who passed the 8th grade, there were at least 450. We use S for the students. At least is greater than or equal to 450. So at least 450 of students passed the 8th grade. But it could have been 451, 452. It does not have a maximum, but it does have a minimum of 450 students. So my model here would be S greater than or equal to 450. That's just how I use those to help me model real-world situations using those inequality symbols. Alright, so some important rules that we need to know when solving inequalities is that when you multiply and divide by a negative number, you must flip. Having issues today. You must flip your sign. Okay, what does that mean? Some of you probably already know what this means, but if I have negative 4 times x greater than 12, when I solve this inequality, just like I would solve a one-step equation, I would divide and undo the multiplication here. So I divide by negative 4 on both sides. And because I'm dividing by this negative 4, my sign is going to flip. So regardless of what my answer is, my sign will flip. I bring down the x, because negative 4 divided by negative 4 is 1. 12 divided by negative 4 is negative 3. So because I divided by that negative, my sign must flip. Now, if I were to graph this on a number line, this will never be something you see on the EOC, but I would just graph this by having a open circle, and I would shade to the left that way. Because my arrow is pointed that way with my variable on the left-hand side, I would point my arrow and shade everything to that direction. Okay? That's just an example of how to shade. With this example, if I have negative x divided by 3 less than or equal to 13. I would multiply by 3 because I have 3 in the denominator. It's being divided. I do the opposite by multiplying. Multiply by 3 to cancel out my denominator, bring down the negative x. Less than or equal to, because that was my sign, 3 times 13 is 39. Then I would divide by this negative 1 in front of my x. So divide by negative 1. Now when I divide by negative 1, my sign will flip, so I have x greater than or equal to negative 39. And again, if I had a number line here with negative 39, this time, just like with the lines that we saw on the first slide, I'm going to have a closed dot, and I would shade this direction. Okay? Something not very important, but you should already know how to shade with the number line. That's something you learned in 8th grade or maybe 7th grade. Okay, so that's just how I use. Make sure you always remember to flip your sign when dividing or multiplying by a negative number. All right? That will happen a lot when we're solving linear inequalities. These were not linear, these were just 2-step and 1-step inequalities. Okay? Next, we have, when solving linear inequalities, there are more than one solution. Okay? What does that mean? Inequalities is less than or greater than. So you can have anything, like I said earlier, anything less than that 12 or anything greater than or equal to that 450. So there could be more numbers than just that one answer. So when we're talking about linear inequalities, if I want to see if a solution, or if I ordered pairs, so say I have the ordered pair 1, 2. If I want to see if that is a solution, all I do, this is my x variable, this is my y variable, I plug these in to see if this satisfies the inequality. So if I have 1 for my x, I'm just going to plug it in by showing parentheses here, plus 4 times my y value is 2, less than 16. Negative 3 times 1 is just negative 3, plus 4 times 2 is 8, less than 16. Negative 3 plus 8 is 5. And 5 is less than 16, so this is a solution. Okay, and I'm writing crooked because it's hard to write on the board, but you need to write that that is a solution because 5 is less than 16. This does make sense. Now, if it didn't make sense, if it said like 25 is less than 16, that wouldn't make sense, and this would not be a solution. But because this satisfies, and this is true, this ordered pair satisfies that inequality, it is a solution. So if we look at 8x times plus 3y greater than or equal to 48, let's say I have the same ordered pair. Let's use 1, 2. This is x and y. We're going to plug it in to see if it satisfies the inequality. So my x value is 1, so I have 8 times 1 plus 3 times 2 greater than or equal to 48. 8 times 1 is 8. 3 times 2 is 6, greater than or equal to 48. 8 plus 6 is 14. And as you can see, 14 is not greater than or equal to 48, so this is not true. So this point right here is not a solution. Okay? So you need to plug in the points when you're given an ordered pair, or if you're given a graph and they want to say, is anything in this shaded region a solution, you need to make sure it is by plugging in these points into the inequality to see if it works or if it does not work. That's how you check to see if it is a solution or not. Those are linear inequalities because you have the x variable and the y variable, just like you see on the graph. Okay, so that's some linear inequalities for you. The next slide we have we are going to be solving these for slope-intercept form. So they said solve the following inequalities for slope-intercept form. And again, slope-intercept of the equations is y equals mx plus b. We no longer have that equal sign. We're going to replace it with an inequality. Same thing here. This is going to help me graph. I undo the addition or subtraction to my y variable. So I have 2x minus 4y. I want to get rid of this thing being subtracted to the 4y. So I'm going to undo it by subtracting it because it is a positive 2x. And And what I do on one side, I do to the other. That cancels, bring down the negative 4y less than or equal to. Cannot do subtract letters and numbers, so I'm just going to rewrite this with my x first. This is just more practice for changing standard form to slope-intercept form. My last step is to undo the multiplication, which is negative 4. Now be careful when I divide here, because my sign will change. So when I do that, I have y is no longer less than or equal to, it's going to be greater than or equal to negative 2 over negative 4 does reduce to 1/2, and it is positive. 16 divided by negative 4 is negative 4. So my sign would now have changed to greater than or equal to. So if I were to graph this, I would get a solid line and shaded above, because it is greater than or equal to. So that would be my equation to help me graph. This would be my y-intercept. This would be my slope. It would get a solid line, and I would shade above. This example over here, negative 3x plus 5y greater than 15. I would add 3x. We're just going to jump right into it. Add 3x both sides because we want to get rid of this addition to the 5y. That leaves me with 5y greater than 3x